Hello and welcome to SciTech Learning Academy O-Level Mathematics tutorial. In this video, I'm going to be talking about how to find the modulus of a vector, or the magnitude, or the size, or the length of a vector. Probably one of the most important things that you have to understand when dealing with vectors is that a vector has got a magnitude and a direction. Today we're going to be talking about the magnitude of a vector. The magnitude is also known as the modulus, or the size of the vector, or the length of a vector. So when you see a question that asks you to find the magnitude of a vector, it's the same as finding the modulus. It is the same as finding the size or the length. Now let us say we have vector AB, which is represented by the line that you see right there, which means it's like a displacement from a point A to point B. Vector AB is got an x displacement, which is the horizontal displacement, and the y displacement, which is the y component of the displacement, that is vertical. So let me label them x right there and y right there, as you can see. So now we have a right angle triangle. We want to find the length of AB, that's the magnitude or the modulus. I'm going to call it h. Now using Pythagoras theorem, we know that h squared is equal to x squared plus y squared. That's Pythagoras theorem. You know that from trigonometry. Which means if we have h squared, we want to find the h, we find the square root of x squared plus y squared. Now that is the magnitude of the vector. So that is the length of the line AB from Pythagoras theorem. So what this means is that if AB is represented by the values x, y, those are the values that represent our vector, the x component and the y component of the vector, the magnitude of the vector becomes the magnitude of AB becomes the square root of x squared plus y squared, as you can see right there from what we proved using Pythagoras theorem. Now let us look at an example using numerical values. In our example, we're going to take the values of AB to be 3, 4, which means the x component is 3 and the y component is 4. As you can see right there, with our AB in column form, that's how we represent our vectors. Now, we're asked to find the modulus of AB, or the magnitude of AB. Finding the modulus of AB or the magnitude of AB, that is the notation that we use. We write AB, then we put it between those lines, those two lines. That's what represents the magnitude, which is equal to x squared plus y squared according to Pythagoras theorem. So in this case, it's the square root of 3 squared plus 4 squared. 3 squared, that's 9, 4 squared, that's 16. Therefore, AB, the modulus of AB, that's the square root of 25. So we can say the modulus of AB, the square root of 25, that's 5. Magnitude is length, so we take only the positive root because length can never be negative. So which means the modulus of AB, that's 5. Now let's look at more examples. Right there I have A, which is 4 minus 3, which means the magnitude of, we are going to want to find the magnitude of the following vectors. B, that's minus 5, 12. C, that's 8, minus 6. D, that's 0, 7. And the question asks us to find the magnitude of those vectors. Let's see. The magnitude of A, it is equal to the square root of the x component plus the y component, which is the square root of 4 squared plus minus 3 squared, minus 3 in the bracket right there. So 4 squared, that's 16. We put our 16 right there, plus minus 3 squared, that's 9, which is equal to square root of 25. 16 plus 9, that's 25, which is 5, just like in the previous example. Let's look at the magnitude of b, vector b. Vector b, the magnitude, that's minus 5 squared plus minus 12 squared, because minus 5, that's the x component, minus 12, that's the y component, which is equal to minus 5 squared, that's 25, minus 12 squared, that's 144. Then we add the 25 and the what, and 144 to get square root of 169, which is equal to 13. Now we move on to the magnitude of c, vector c. Magnitude of vector c, as we previously stated, that's the square root of x squared plus y squared, which is 8 squared plus minus 16 squared, because the 8 is our x, then the minus 6 is the y, which is equal to square root of minus 8 squared, that's 64, then minus 6 squared, that's 36, as you can see right there, which gives us the square root of 36 plus 64, that's 100, square root of 100, which is equal to 10. So the magnitude of c, that's 10. Magnitude of d right there, same applies, just like in our previous examples. We can see that the square root of 0 squared plus 7 squared, the x and the y values, which is the square root of 0 squared, that's 0, 49 squared, 49, that's 7 squared, which is about the square root of 49, which is 7. So as you can see, that's how we find the modulus, the magnitude or the size or the length of a vector.